Good morning. I'm Swati Singhal, a graduate student from University of Maryland, and I'm presenting DYFLOW, a flexible framework that enables orchestration of scientific workflows on supercomputers. So why do we need to orchestrate scientific workflows? Modern scientific workflows are complex. They involve a large number of complex tasks that come from multidisciplinary areas. These workflows are data intensive, and hence it is often practical to run them in situ, where workflow tasks run simultaneously and exchange data using on node or off node memory buffers. Because of all these complexities, the runtime behavior of these workflows are becoming unpredictable, and there are many dynamic challenges. For instance, when tasks are sharing compute nodes, they interfere with each other performance. There are unpredictable changes in the rate of data flow between these tasks. There are failures, and since the analysis are done online, there needs to be automatic way of handling various data-driven events. The support for this on supercomputer is either limited or not commonly available in practice. The nature of resource assignment is pretty much static. User have to allocate everything in advance and decide on initial resource assignment and then hope for the experiment to succeed at runtime. To avoid performance bottlenecks, users tend to over allocate resources to their node, which results in most of the time underutilized resources. There are many workflow management services that has eased this process for the user, but and support some orchestration, but there is a huge gap that needs to be filled. And there's where DYFLOW come into the picture. DYFLOW is not a new workflow management system from scratch. Rather, it's an orchestration service that reuses most of the or runs on top of most of the existing workflow management system and adapts user workflow based on custom requirements. So how does DYFLOW work? DYFLOW uses a generic dynamic model that compartmentalizes workflow management into 4 stages. These stages run continuously and simultaneously alongside the user workflow and process the incoming request to as and when necessary to manage the orchestration based on the user defined settings. For customization, we provide users with comprehensive constructs at these stages where user can express how do they want to monitor, how do they want to manage these different stages. And these stages are easy for users to express their requirements, and they are reusable across different workflow tasks and parallel machines. The first stage is the monitor stage. This stage is responsible for collecting all the monitoring data in real time. This collection may signify a read from a database or streaming into the workflow applications and collecting various statistics or reading from a file. Since the collected data could be huge and raw, this stage is also responsible for processing this data and reducing into something more simple and easy to process or easy to analyze values. For customization here, the constructs allows user to set sensors. Each of the sensors allows user to specify what information they want to gather at runtime and how this information can be accessed, what is the data gathering method, and the user wants to group and reduce this information to simplify it. The framework manages this sensor at runtime, sets and resets them as the tasks run and go. And framework manages the collection of data at scale. And then framework also allows users with different kind of gathering methods, grouping and reduction method to help user customize its requirement. The second stage is the decision stage, which takes the simplified reduced matrices and evaluates them. It checks to see if there is, based on this evaluation, it determines if an interest of event has happened. If such an event happens, it forwards certain suggestions to the next stage. The user can, in the stage, can customize what kind of policies they want to establish at runtime. Each policy determines an evaluation condition which represents an event of interest. In response to this events, user can suggest what kind of actions they want to perform for their workflow. They can also set the frequency at which they want this evaluation to happen. The framework manages these policies, trigger the evaluation as requested by the user, and allow users with different kind of evaluation conditions and high level actions, so that which enable users to customize their need. The action here are high level because these are user friendly actions which encapsulate various kind of system or management level functions that are required. The next stage is the arbitration stage, which takes the incoming suggestion and formulates a plan which is feasible at runtime and leaves the workflow in a consistent state. Since users can set up different policies and which can suggest many different actions at different times, but not all the actions may be feasible at runtime. There could be conflicts between the actions. There could be dependency that needs to be resolved in order to execute them. And depending on the status of the resources, that is, what are the healthy resources, free and assigned resources, not all actions are performable. Also, these actions need to be mapped to the lower level system or management level functions. So all these are responsibility of arbitration. Arbitration manages all this control and can also occasionally decide to suspend its processing, since it already applied certain changes to the running workflow and it wants those changes to get settled in and this avoids repeated application of the same suggestions that it just performed. So, and framework controls most of this layer, this stage, but users can set up certain rules where they can set task priorities and where they can specify task priorities and task dependency. This help arbitration in conflict resolution and identification of dependent actions. The last stage is the actuation. Actuation stage is responsible for executing the plan that arbitration has sent it. For execution of this plan, the arbitration may require to send certain control signal to the running application, or it can delegate the action to the workflow management underneath workflow management service. For instance, it can request stopping a task, starting or relaunching a task with a certain resource assignment, or it can make various inquiries about resource status or resource assignments. This layer is not for the end user, but for the workflow developers to write to extend DYFLOW by writing their own plugins. These plugins enable actuation to invoke different functions in the workflow management system. And framework support this by providing wrappers. Wrappers include what kind of services will be requested by the actuation at runtime. So what are the DYFLOW capabilities? To demonstrate the use of DYFLOW in practice, we implemented DYFLOW as a Python library, which is currently integrated with Cheetah Savannah management workflow management system developed by Oak Ridge National Lab. For user dynamic needs, we provide the easy to use XML interface. Through experimentation, we have provided many scenarios which demonstrate that DYFLOW can improve throughput, performance, or handle node failures, and many data-driven events. In this presentation, I will be discussing the scenario where we demonstrate the handling of node failures. This scenario is simple to explain and very relatable. In this scenario, we used the molecular dynamics LAMS code where simulation was tightly coupled with 3 different analyses. The experiment was run on Summit. And to accommodate the node failures, we set up a sensor that reads the error status of the task and collects it for the first process. On top of this, we set up a policy that compares this error status with against 128. If the error status is greater than 128, then it signifies a failure from system, a system failure. And in response to this failure, we restart the task. And this evaluation happens every 30 seconds according to this policy. This graph shows the runtime of the experiment. All the timestamps are relative to the start of the experiment. We allocated 52 nodes for this experiment on Summit, and 50 of which were used for the experiment. All the tasks start from the beginning simultaneously. Simulation used 1500 processes and all the analysis used 200 processes. After about 10 minutes into the experiment, we deliberately took one node out of the service, which fails all the tasks. And when DYFLOW recognizes this failure, it immediately restarts all the tasks using one of the spare nodes in the allocation. If there are no spare nodes, DYFLOW will make attempt to start the higher priority processes. Uh, in this case, simulation starts from the last checkpoint, and this is enabled by the LAN's checkpointing service. The total time when the event happened and when the workflow restarted was 30 seconds. DYFLOW itself didn't take any time to restart the workflow. All this time comes from the decision frequency of 30 seconds. Uh, for future, we are considering two directions. One is to improving arbitration stage, where we want to improve the resource reassignment decisions. Since compute nodes are becoming resource intensive with many heterogeneous nodes packed in it. So there are many opportunities to improve those decisions. We also want to use machine learning to improve the other decisions, such as conflict resolution and setting priority policies to make and learning from the history. The next direction is the actuation stage, where we want to explore what kind of controls we can provide to users that will enable a better dynamic management. For instance, controlling what and how the data flows between the different tasks. To summarize, DYFLOW is an orchestration service that automates the process of workflow management for user and acts on custom user requirements. It's not about a brand new workflow management system, and reuses most of the existing support from the workflow management services. Through experimentations, we have demonstrated that this DYFLOW supports adaptive workflow and provides various capabilities. Thank you.